Good morning, everyone. I'm Kirtana PK. Today, we are going to explore a powerful and elegant concept in artificial intelligence known as Blackboard architecture. This is a design paradigm specifically created to help intelligent systems solve complex multidisciplinary problems. So, what exactly is a Blackboard architecture? At its core, it's a problem solving model where you have multiple independent knowledge sources that all collaborate to solve a problem. The key and the main difference from other systems is how they collaborate. Instead of communicating with each other directly, all contributions flow through a central shared data repository called Blackboard, and this enables a very modular and flexible system. The analogy on the slide is the best way to understand it. Imagine a team of experts trying to solve a detective case. You have a detective, a forensic expert, and a psychologist all in the same room. Next, we are discuss about the key components of Blackboard architecture. This architecture is defined by three essential components. First one is the Blackboard. This is shared global database. It stores the current state of the problem, all the intermediate result and the different hypotheses being considered. It is accessible to all the knowledge sources. And the second one is the knowledge sources. These are the experts from our analogy. Each one is an independent specialized module that contains the domain, expertise, and strategies for one specific part of the problem. They operate autonomously. The third one is the control mechanism. This is the traffic cop or the scheduler. It's critical piece that monitors the blackboard for any changes or new information. When the changes occur, the controller decided which knowledge source is the most relevant to activate next and manages the overall flow of the problem solving process. Next, we are discuss about how it works. Let us walk through the dynamic flow of how a problem is actually solved. It's continuous interactive cycle. Step 1 is initialization. The process begins when the initial problem data is posted to the blackboard. The control mechanism sees this and awakens any knowledge sources that are relevant to these initial conditions. Second step is activation. At this point, all knowledge sources are independently monitoring the blackboard, looking for conditions or data that match their expertise. When a source sees something it can work on, it activates and evaluates its applicability. The third step is contribution. The activated source performs its task. It might propose a new solution, refine an existing hypothesis, or add new data. It then writes these updates back to the blackboard. And the last step is iteration. Fourth step. This is a crucial part. Those new changes on the blackboard now trigger other knowledge sources. The cycle of activation and contribution continues, with the solution being built up incrementally, piece by piece, until a final solution emerges or a specific termination criterion is met. Next, discuss about the advantages of Blackboard system. This design offers some significant advantages, especially for complex problems. First one is modularity. This is the primary benefit because the knowledge sources are independent. They can be developed, tested, and maintained separately. You can add new expertise and new expert to the system without having to modify any of the existing components. Second advantage is scalability. The system can easily grow by adding more specialized knowledge sources. This design also supports graceful degradation. If one source is unavailable, the system might still find a solution, just perhaps less efficiently. It's also highly parallelizable as different sources can be run on the different processors. Next is flexibility. The control strategy can be very dynamic. It allows for opportunistic reasoning, meaning the system can pivot and explore a new promising path as soon as a new important clue appears on the blackboard. This makes it perfect for uncertain or ill-defined problems where a rigid step-by-step plan would fail. Next is the real world applications. This architecture is not just theoretical. It has been used to solve very difficult real world problems. A classic example is speech recognition. To understand spoken language, a system has to combine many different types of knowledge. An acoustic source processes sound waves. A phonetic source identifies syllabus, a linguistic source handles grammar, and a semantic source figures out of the meaning. All these sources collaborate on a blackboard to interrupt what's being said even in noisy environment. The second application is in robotics. An autonomous robot needs to coordinate modules for vision, path planning, arm control, and safety. The Blackboard allows these different systems to share their data and coordinate decisions to navigate and act in dynamic settings. And it's also used in medical diagnosis were different specialized knowledge bases, one for imaging, one for lab results, one for patient symptoms, can integrate their findings to help recommend a comprehensive treatment plan. Next, we are discussing the designing a blackboard system. If you were to build one of these systems, there are few key design practices to follow. First one is define clear problem decomposition. You must break the problem down into independent knowledge domains. Each source needs to address a distinct aspect without being tightly coupled to or conflicting with the others. Second is the structure the blackboard data hierarchy. The blackboard itself can't just be joystick data dump. You need to organize the information into logical levels to allow for efficient queries and clear communication. Third is implement a robust control strategy. The controller is key. You have to decide how it will schedule tasks. It is priority based, opportunistic. You also must establish clear termination conditions to avoid infinite loops. Plan for extensibility. A good decision plans for the future. You should design interfaces that allow new knowledge sources to be seamlessly integrated later on, perhaps even at runtime. Next, discuss about the challenges and the limitation. Now, as powerful as this is, it's not the right solution for every problem. It has some significant challenges. First challenge is debugging complexity. This is the big one. The execution flow is non-linear and opportunistic. This makes it very difficult to trace a reason for a particular decision. Second is performance overhead. All the reading and writing to a central shared repository can create bottlenecks. Next is knowledge source conflict. What happens when two experts disagree? You have you can have competing hypotheses and conflicting recommendations accumulate on the blackboard, which requires you to build complex conflict resolution strategies. When to avoid it, because of this overhead, it is unsuitable for simple, well defined problems where a clear algorithm already exists. It's also overkill and generally too slow for real time systems that have very strict latency requirements. Future trends. We are seeing machine learning integration where the knowledge sources are no longer just static rule-based system. Now they can be pre-trained neural networks or other learnable models. The blackboard becomes the space where these different models aggregate their predictions and confidence scores, creating a powerful hybrid system. The creators at deep learning synergy, you can see you can use deep learning models for what they do best, perception and pattern matching, while the blackboard handles the high level reasoning, planning, and the integration of that information. The key benefit here is interpretability. Instead of one gain black box model, you have smaller specialized models who contributes are tracked on the blackboard, which help explain how the system reached its conclusion. Next is embracing Blackboard for complex AI challenges. So, to wrap up, what are the key takeaways? Blackboard system provide a modular excellence. They allow us to elegantly decompose complex problems and let specialized modules collaborate without rigid, brittle integration. They enable adaptive intelligence. The dynamic control allows for opportunistic reasoning, which is essential for handling a uncertainty of real-world problems. It truly remains cornerstone paradigm for building intelligent, collaborative, and adaptive problem-solving system across huge range of domains. Thank you very much. I would be happy to take any questions. Thank you so much.